Hey guys, welcome back to another video. This video is on the nomenclature of alkyl halides. So if you see a hydrocarbon chain that has maybe a chlorine in the middle, how do you name that? And that's basically what this video is going to go over. So let's get started. I have some basic naming principles for the IUPAC nomenclature. And you guys have definitely seen this before. Remember, we went through nomenclature for alkanes. We have to do the same thing. We have to identify the name of the parent. We have to identify and name the substituents, so stuff that is not on the parent. We have to number the parent and assign a locant, which means just like assigning a name to each substituent. So example, if you have one carbon going out on a substituent, you would name that a methyl. And then you would assemble those, substituents alphabetically. So there's really nothing new. It's just adding some new words and some new compounds in your total nomenclature name, you could say. So the only thing that's new here is assigning the locants a name for the substituents. So you need to know what to call a bromine for nomenclature. Maybe a chlorine, maybe iodide, maybe fluorine. So you need to know how to abbreviate that for this nomenclature. And luckily, I have it written right here. So you will never see, the bromine or chlorine as in the parent, because remember, the parent is just the carbon chain. So you'll see it always as a substituent. And just like how we have, let's say we have a 3-carbon parent chain that is, again, a propane. Let's say we have a methyl here. That wouldn't be methane. Remember, that's methyl. That'd be methyl. So same thing. It wouldn't be, let's say this was a bromine. This wouldn't be 2-bromine pentane. It would be bromo. So it's the same kind of thing here. This would be 2-bromo propane. Okay. So for this question, it asks to assign the systematic name for the following compounds. Feel free to pause it if you want to have some more time, but I'm just going to go through it. So the first step is to figure out what the parent chain is. The longest chain of carbons would be your parent chain, and this looks like a simple long chain of carbons. So now we just have to count our carbons. So 1, 2, 3, 4, 5. 5 carbons would be pentane. So our parent is pentane. And then we have to see, our second step is to decide, what the substituents are. So we have bromine, so that would be bromo, and we have 2 bromines on the same carbon, so that'd be di-bromo. And then we have chlorine, so that'd be chloro. So we named our substituents. Now we have to decide how the numbering works. So if we started numbering over here, 1, 2, 3, 4, 5, our first substituent would show up on carbon 2. Now we could do something that's a little better and decide we started numbering the other way, from right to left. Now our first substituent shows up on carbon 1, and that's better than carbon 2. All right, so this would be 1-chloro, and this would be 4-dibromo. Okay. Now, third step for this IUPAC nomenclature is putting it all together alphabetically. So A, B, C, D, C. C goes before D, so it'd be, the final name would be 1-chloro, 4-dibromo-pentane, and that would be the name there. All right. For this next problem, we have a cyclic compound. So this would be 1, 2, 3, 4, 5, 6. So our parent is a hexane, but since it goes in a ring and it's cyclic, it's keep spelling it right. Cyclohexane. That's the parent name. Oops. Trying to add them together a little bit. There we go. So now we figured out the parent. Let's see what we can do. And why I started numbering at 1, 2 on that side is because if we did it the other way, how would the numbering work? It would go 1, 2, 3, 4, 5, 6. We would have on the 6th carbon our substituents, and it's better to be on 2. Remember, we want the lowest number possible for our substituents. So naming these compounds on here, this would be a methyl, and this would be a bromo. So B comes before M, so we have 2 bromo, 2 methyl cyclohexane. And that is your name there. We have this compound. This is a halide, so we have 2 halogens connected to this hydrocarbon chain. So 1, 2, 3 doesn't really matter where you number it. You can do 1, 2, 3, and you would get the same thing. You would get a substituent on carbon 1 and carbon 3, and they're the same substituent. So for this one, our parent is a propane, because we have 3 carbons, and we have a 1 chloro, and we have a 3 chloro. So in our name, we can do 1, 3 dichloropropane, and that's the name there. I believe we have a couple more for names. Hopefully this one makes sense. Our longest chain here is 1, 2, 3, 4, 5, 6. And I numbered it that way because I realized that this is coming out here. So we need that to be included. But that's actually the wrong way to go about it, because that doesn't actually include our halogen. And one of the major rules in this chapter is that your parent chain has to include your halogen. So we don't know a name for a substituent that shows a methyl and then a bromine. So you have to start numbering to include this bromine, even though it's not the longest chain of carbons. That's just the way you have to go about it, because that halogen has a far bigger importance than just having the longest chain of carbons. So our numbering goes like this, and then we only have, so this would be a pentane as our parent chain. And then looking at naming our substituents here, we have a 1 bromo, it's on carbon number 1, and we have a 2 ethyl, because we have 2 carbons there. So our final name is 1 bromo 2 ethyl pentane. And that's the final name there. So you really have to remember to include this bromine, because as I was going through that, I was like, well, there's not a name that you can do where you have a substituent that's a methyl going into a bromine. So always remember to include those halogens. All right, moving on. We have this one to focus on, so feel free to pause it again and go through it yourself. This one incorporates a wedge, so we have to think back to our R versus S configuration and think about, is this an R configuration or an S configuration? Because we need to write that in your nomenclature. So let's actually do that first. Let's determine if this chiral center, remember a chiral center has 4 distinct groups attached to it, and we have a hydrogen, bromine, methyl, and ethyl group attached to it. So since that's a bromine on a wedge, our dash will be that hydrogen. If I want to assign numbers, that hydrogen is number 4, that bromine is number 1, because it's bigger than the methyl and ethyl and more electronegative. Our ethyl has a higher priority over our methyl because it's bigger, so our numbering will go like that. So does this go in clockwise or counterclockwise? It looks like it goes in clockwise, so that's an R configuration. And we don't have to switch anything around because our dash is on our lowest priority, so the way it goes around right now is the way the configuration is. So this is an R configuration. So I'll erase all this and just write on this chiral center, I'll write a miniature R so I know to go back and write that R in my nomenclature. So numbering this and actually going on to the nomenclature, we have a butane as our parent chain, and we have a one substituent, we have that bromine, so that would be a 2-bromo. And where do you add that R into? Well, you actually do something like this. You do 2-R-bromo, and you add it in those parentheses because when you get into more complex compounds, you really need to differentiate where that configuration is, because maybe we had a chiral center right here and you would have to do 3S and have to have that in the name as well. So this would be 2R-bromo butane. Our next one right here, we have 1, 2, 3. And again, you could do, for this one, it all stays the same. You could do 1, 2, 3 if that makes more sense. So we have another propane as our parent. And you actually want to number it the other way, because then we would have our lowest number substituent on 1. So this, for this compound, again, what are our substituents? We have a 1-chloro and we have a 2-dimethyl. Remember that di indicates that they're both on the same carbon chain and there's more than one. So writing that into our full name, we have 1-chloro, 2-dimethyl propane, and that's the name there. All right, that is the end of this video. Hopefully that helps, and you can now get into substitution and elimination, which will be the next video. Have a good one, guys.